Hello everyone, welcome to my YouTube channel. This is Appu Rathod. Today I am came with one of the interesting concept in a discrete mathematics structure, that is function composition and inverse functions. So let's move toward our introduction. Function composition and inverse functions are the fundamental concepts in the mathematics, and particularly in calculus. They offer a powerful way to analyze and manipulate functions, providing insights into their properties and relationships. So now definitions of the function compositions. Functions composition combines two functions by applying one functions to the output of another functions. So given two functions f and g, the composition of f with the g denote f of g of x evaluates g of x first, then the is applies f to the result. So what's the range between these two functions? That is the f of g of x are the set of all values of f of g of x can be taken on for a x is the domain of g. So domain of the f of g of x is the set of all x in the domain of g for all g of x is the domain of f. So notation and properties for function of a composition. So function composition is a fundamental concept in the mathematics that allows us to combine two functions in a specific way. This operations has a distinct notations and follows key properties that make two powerful tool for analyzing and manipulating functions. The notation for function composition is either f of g of x or f of g of x, where inner functions g is applied first and the result in the pass to other outer functions f. This notation is important to understand as it reflects the order in which is the function are combined. One of the essential properties of the function composition is associative, which means that the order in which we multiple compose multiple function does not affect the final result. In other words, f of g of x or f of g of h, this property allows us to simplify complex composition by breaking them down into smaller, more manageable steps. Another important property is the identify function, denoted as a id of x. This function simplify returns the input x, and it has the x, and it has the unique property that f of x of id of x is equal to id of x of f of x equal to f of x, meaning it does not affect the function original function. So finally, the concept of the inverse function denote of f inverse of x is closely related to the composition function. The inverse function undergoes the original function, such as the f of f inverse of x equal to f inverse of f of x equal to fd of x. This property is crucial for solving a wide range of mathematical problems and understanding the behavior of functions. Let's move towards our inverse function. So inverse function is the action of the original function. For a function f of x has to be inverse, it must to be a one to one, meaning each output corresponds to the unique output. So relationship f of f inverse of x equal to f inverse of f of x equal to x. How to find the inverse function? So finding the inverse function involves the series of steps to reverse the process of the original function. In step 1, replace the f of x with a y, and step 2, swap the x and y. In step 3, solve for y, and step 4, replace the y with the f of f inverse x. So let's understand with the example. Graphing inverse functions. The graph of a function and its inverse are reflection of each other across the line f equal to x. This symmetry arises from the swapping of the x and y in the inverse function. So original function is f of x and its reflection is y equal to x, and inverse function is f inverse of x. So understanding the now applications of a function composition and a inverse function. Function composition and inverse function function finds applications in a various fields including calculus, cryptography, and computer science. Calculus means it's chain rule, and cryptography means and computer science means data for transformation. So let's end this topic by reading the conclusion. So conclusion is the function composition and inverse functions are the powerful mathematics tools for analyzing and manipulating function. They enable us to the understanding how functions interact, inverse their functions, and apply them in the various field. So take key one is function composition combines two functions, and key two is the inverse inverse functions reverse the function as the original functions, and key three is the applications include calculus, cryptography, and the computer science. Thank you guys. Thank you for watching.